Welcome back to Number Math, in which we apply color to identify and sequence within Math My Unit 2 crew. This is your Unit 2A review. Kicking it off, we do have a beautiful resource tool that Number, yes, Richards did create. And here we go, okay? When we are given our quadratic functions, you'll see them in three forms on this one. You'll see them in standard form, vertex form, and factored form. Okay, so just take a look at the way things are written. All right, we use the color to identify, and in factored form, we can identify the A, but when we distribute out, it will go back to standard form. Okay, so taking a look at standard form, the advantages are we can identify the A, B, and C values. Very simple. Yes, okay. Forget all that nonsense for now because the y-intercept, this is the kicker. It simply equals 0 in what our C value is. So when we are taking a look at 2x squared minus 8x minus 64, if we were to find our y-intercept just by simply identifying, all right, well, let's go ahead and open a parenthesis. Let's go ahead and plug in a 0. We're going to close it. And then our C value, well, it's the green number, in this case, our constant here of negative 64. Go ahead and plug that in. You now have your y-intercept. Also, you can begin to work for your axis of symmetry using x equals, all right, the opposite of b over 2 times a. And then we can begin to solve for the axis of symmetry, later plug in to find your y, giving us the vertex. Now, when we are working in vertex form here, f of x equals a, open the parentheses, x minus h squared plus k. Okay, let's take a look. Here is a function given to us, all right, of f of x equals 2. Ooh, okay, x plus 4 squared minus 8 there. Identify the vertex. Well, to identify the vertex, this is the advantage. Let's go ahead and open up some parentheses here. Now, I know that doesn't look the cleanest, and I'm not too sure why. However, but let's do some identifying, okay? This is our A value. The 4 is our H value. And the negative 8 is our K value. However, I know that when we do negative 1 times H, or negative 1 times a number, it simply flips the sign of it. So if we did negative 1 times 4, well, that would give us negative 4. So we can simply plug that in. Our K value stays the same at negative 8, and go ahead and write your vertex. Now, when we are in factored form, okay, again, we can simply identify the A value. Wonderful. But the advantage here is identify the x-intercepts by setting y equals to 0. We will do this later. Also, take a look. Yes, if you need to go back to this and reflect upon it at all, take a look, okay? This is how we sequence through. This is how we solve specific things. This is what this means to us, all right? Now, once we got comfortable with identifying the x-intercepts in factored form, well, it's typically very simple for us because we're just taking the flip of the 6, making it negative, comma, 0, close it. Yes, negative 6, comma, 0, close it, and exactly 3-0. Wonderful job. We'll continue. Now, however, when you are looking at number 1, all right, if the question asks you which function does not have a minimum, check the provided answer choices for the parabola that frowns like the negative A value it is. All right, because when it's frowning, well, the frown will give us our maximum. So it does not have a minimum. You will be looking for max. Or if it asks you which function does not have a maximum, then check all of the provided answer choices for the parabola that smiles because of its positive A value. All right, so let's go ahead and kick some off. We'll use the colors, then we'll go to black and white. All right, so we're just checking answer choices to see if they are going to give us a min or a max simply by the A value. Okay, so right here, our A equals, yes, negative 4. Now, because it's negative, negative people sometimes frown. All right, well, if we did our parabola like that, we're just going to draw it maybe for the first couple. Well, we're going to climb that mountain. We are going to get that max point. All right, so this is going to give us a max. Now, if you work below, feel free to pause the video briefly, but I am going to go through it in black and white. Okay, so what is our A value here? Ooh, no, it's not x squared. It's the imaginary 1 I'll put in gray in front of x squared. Go ahead, when you're taking your notes, put the 1 in there. Doesn't matter. If that benefits you, use it. All right, so A equals 1. What do we know about that A? Yes, it is positive, and positive people are just walking around smiling. All right, and then that will give us a minimum down to the valley. Go ahead and circle your min. We will try this now with our vertex form. The A equals, yes, when we see that negative in front of it, great job, whomever said it. It's -1. Okay, and what do we know about that -1? Yes, our parabola will frown, giving us that max value. All right, if you want to pause the video briefly before I do go through it, we will work through this one in Vertex, all right? But I'm just going to continue with this one because I'm getting students to shout out answers. Our A value is yes, it is 0.5. So wonderful job there. And that is a positive 0.5. It's going to be smiling today. I love when I get my parabola clean. It must be because I'm happy and getting a minimum with my positive A smile. Yes, now. Moving forward, factored form. Now, sometimes we might get a little confused. It's like, oh, does it go here? Does it go there? I'm not too sure where, but let's go ahead and write it in. And please feel free to do the same on your notes again as well. All right, so I will put that 1 there. We do know it's positive. It is going to be smiling, and again, giving us a minimum. Now, the reason I wanted to do this is for 2 specific reasons, okay? 1, we can simply identify the A. You don't have to plug in the entire function in a Desmos just to have it graph the parabola and tell you whether it's a frown or a smile, okay? You can just determine that through the A. Also, on your next one, we can't use any Desmos. All right, so moving forward, let's try this one in black and white. You guys are absolutely killing it. Yes, the A equals -1. Yes, it is a frown, and yes, it will give us a max. Great job. Moving forward, number 2. Determine the y-intercept of a quadratic function in standard form. All right, we did it when we just did the review. We know that when we're given a quadratic function in standard form as so, well, our y-intercept is just going to equal 0 and whatever our c value is. Yes, please keep your answers to yourself. And yes, I do love the participation as always. But for those that are taking notes and potentially learning at home, y-intercept equals, we're just going to take this right here. And I am going to boom, open, boom, 0, boom, comma. I'm going to close off a little early just to identify my C, which is -44. All right, moving forward, let's go ahead and try that one in black and white right next to it. And again, I'm just going to switch colors, and we will do this entirety in black and white. And what I like to do when we work through black and white is just label it for you. All right, you might want to underline it. Go A, underline it, go B, underline it, go C. All right, because that way you're building that comfortability later as you continue. That's why the practice builds the proficiency. All right, so y-int equals 0, comma, c. Well, we're just going to do our 0. Our comma and our c value is, yes, -18. Wonderful work. Close it, and you are good to go. Working for number 3, find the vertex of the function and determine whether it provides a min or max. Okay, here we go. Vertex form. When we are given a function in vertex form, the vertex equals the flip sign of h, followed by the k. All right, let's just go ahead and do some identifying. All right, well, our negative there, what is that? Yes, it is our a, and our a equals -1. All right, now our h value, yes, great job, it is 7. Did I hear it? The flip sign of h. All right, so let me write it for us. I'm just going to do it in black just so I can see how I just want you guys to know how it goes. -1 times h. Well, if we did -1 times 7, yes, that's exactly why it's the flip sign, because now it just becomes -7. Wonderful job. And let's go ahead and underline our k in green, which is 9. So if we were to write the vertex, all right, let's do vertex equals All right, well, let's just go ahead and look at the formula. It's the flip side of h, which we've already identified. All right, -7. I'm going to go ahead and put that in. I will add my comma in there, and then just followed by our K value, which stays the same, which in this case is, yes, the Jordan Olympic at 9. Go ahead, and that is your Vertex. Well, let's try the one in black and white. Okay, again, same thing, guys. I love to label. You know I do. There's our A, there's our H, and there's our K. Great job. Ooh, you know what? Definitely forgot to tell whether this was going to give us a min or a max. Great job. Our A is negative, so our parabola will frown, ultimately giving us a max. All right, the vertex is always going to give you the min or the max. All right, so moving forward again. So we have our positive A. What does that positive A tell us about our parabola? Yes, it will smile, you positive people, you wonderful young folk. You're so amazing and incredible. Thank you for the assistance. All right, now let's go ahead and do our vertex. All right, well, our A equals 2. And if our H equals -5, well, what's the flip side of a -5? Boom, write it, correct, +5. Plug in your K value, which in this case is -8, way to identify. And as you can see, a lot of this quiz or unit assessment, guys, is simply just identifying, all right? Get comfortable with it. Let's roll. Number 4, find the x-intercepts of a quadratic function in factored form. X-intercepts always represent the x values when y equals 0. All right, now, I saw this on our last quiz. I was slightly disappointed. Some of us found the x-intercepts no problem, whether that be Desmos or solving it by hand. Whatever you chose is okay by me, but then we selected the wrong answer. We selected y-intercepts always represent the y values when x equals 0. Oh my goodness, it just totally did not make sense. But let's just go ahead and go through this because next one, guys, you cannot use Desmos. All right, so f of x is y. Y is f of x. So when we take our binomial, we take our little x plus 4 here, and we set it equal to 0, well, how would you get x by itself? Yes, amazing job. -4, the negative BZ, we'll call it right now. All right, that goes out to the old school crew. What up, BZ? Holler at your boy number 4. Bring down your x, give it a cross, equals -4. All right, making your x-intercept -4 and 0, because anytime we are working with x-intercepts, it will always be a number followed by 0. And whenever we're working with y-intercepts, it will always be a 0 followed by a number. All right. Now, if we were going to do this one, take a look, guys. What did we simply do? Well, if this was a +4, we just made it a -4 and then put in our 0. But we will solve this one clean. Didn't mean for the highlighter. Let's get back to pen mode. X, didn't mean for that either. -15 equals 0. Simply solve for x. Do you actually have to solve for x? No, I'm just giving you the reasoning. All right? If you can simply identify right away, heck, we're just going to take this -15, drop it, go 15, 0, done. Circle your answer, but make sure you put it's the x values when y equals 0, because even when you look at your coordinates, if they go x, y, well, your x is 15 and your y is equal to 0. All right, we will just go ahead and jump to the one in black and white here. I did hear an answer. Do you want to shout it? Yes, you can. -8, 0. -16, 0. Wonderful. Why did you do it? I don't understand. Why did you go negative? Yes, you're simply just taking the +8. You're flipping it to a -8. You're going by 0. And just in case you want to use that as a note for tomorrow, what I would do is I'd just draw like a little line and just put flip sign. And again, if you do that, we will take your answer. All right, if you get a little confused or you just want that note for tomorrow, boom, put it there. Flip sign. All right? Don't be shy. No shame in numbers, math game. All right? Number 5, moving forward, and yes, I didn't want to go through this. Teacher will hate me for this trick. I know, I kind of made this up as the opposite of y and 0 because you can simply do that, and all of a sudden, if you take the opposite of y and then followed by the 0, I don't even want to go into it. It's not even that great. Number 5, find the axis of symmetry of the quadratic function. Sure, guys, same thing. You could plug all of these into Desmos, but let's go ahead and work it through. Let's do some identifying. All right, what is our A value? Great job from last time. And if you do, again, want to put that imaginary 1 in there for your notes, do so. B equals, yes, -2. Let me get that in blue. And our C is, excellent job, -15. Okay, now what I'm going to do, just like I did in class, I'm going to go ahead and copy this. Let me make it a little tighter because I think it might pick up some letters that we don't want it to. All right, so we're just going to move this here. And I'm just going to walk you through the process here. Well, if our axis of symmetry, and actually let me do this, you're going to want this as a note. Some of us still, not 100% on it. I want to make sure you're clear for tomorrow. All right, it's your x value of the vertex. All right, definitely jot that down if you're uncertain. All right, now we're just going to simply plug and chug. All right, I will give you the full breakdown, but no, do you have to write it out like that? I don't expect you to. If you're comfortable with your mental math, use it. All right, so let's take a look. When we have this -b here, well, it's just telling us to do -1 times our b value, which is -2. And again, this is why I always say to go with the flip. Because if we did -1 here times -2, well, that's simply just going to give us a +2. And then we will set that over 2 times our A value. So let's do a 2. And what did we identify as our A? Yes, we did with 1. Great job. All right, 2 times 1 equals, great job, of 2. And we know that any number divided by itself is simply 1. Great job. I'm also going to highlight that in orange because it will come up in just a little bit just down below. Ooh, I don't like that. It's got to be clean. One swoop. All right, there we go. Doesn't look the best, but we're clear and we're there. All right, let's go ahead and continue. Let's try this one in black and white. All right, just in case we're uncertain about our labeling, guys, if you're just tuning in, you're just jumping around to this one, feel free. A is -2, B is 9. Ooh, that 9 looks like an A. C is 18, my dad's B day. Oh my goodness, and the month. Yes, I know. Sometimes it just shows up that way. And again, we're just following the formula, but this time we're going to use some mental math, all right? I know if I do -1 times any number, it's just flipping the sign of that number. So this is just telling us to take the flip of B. Well, our B is 9, so it's just going to be x equals -9 over 2 times our A value. Well, 2 times -2 is simply -4, and that will equal 2.25. All right. Didn't mean for that. Meant for the highlighter in orange. Let's go ahead and fill that in. Only reason being, now the way I drew this up just to show you so we didn't have to work through another, yes, you can simply use Desmos, and I will repeat that multiple times. But I drew these up to match identical, these functions here. That way we can simply just take the vertex of what we just used. And yes, if you want to take it by hand, feel free. There's a couple of ways to do it. I will simply just write it out by every time we see an x within our function. All right, I see one here and I see one here. We're just going to enter in the number 1 in parentheses. Got to wrap in parentheses. Oh my goodness, where do we start? With an x. What do I do then? I do wrap a 1 in parentheses. Let me get back to, there we go. All right, and then we're simply just going to follow along with the function. It tells us to square it. We are going to do -2. We're just writing it through. Yes, there's an x, and boom, we will put that 1 in parentheses. And, ooh, did not mean for that. Didn't see that one coming. All right, -15 equals, now if you use a calculator, well, let's take a look. The 1 squared is still just simply going to be a 1. -2 times 1 is -2. Got to work the PEMDAs, parentheses first. Drop down that -15. Goodness, I'm getting sloppy with my writing. I'm not too proud or happy about it. But 1 minus 2 is negative. 1 minus another 15 gives us the negative sweet 16. Go ahead and circle your answers. Now, if you want to test the other one, feel free. All right, we did do it in class, but let's go ahead and work it. Do you guys want to work it? Sure, we'll work it. All right, let's just do the function this time all in black and white. We open with that negative 2. I'm going to drop it all the way over here because I did run out of a little bit of real estate earlier in class. We are going to wrap that 2 1/4 in parentheses. We're going to close it. We're going to square it. We're going to do plus 9. We're going to open parentheses, 2.25. Boom, plus 18. Equals. All right, I have my Desmos coming in. I do not have my calculator. It's going to take me a minute. Let me see if I can pull it up from here. Nope, not the right one. Let's see if we can drop it. We can. Beautiful. I'm also just going to get rid of it for now. Maybe it slides back in. No, it goes back to Desmos. Darn it. All right, let me try it one more time for us. Actually, we'll put it over here. All right, that way we can clear it out, and then we can simply type it in. We are just going to enter it as we see it. Ooh, goodness, I just want to get this over here, this over here. I need to calm down. Mr. Nimber, take a deep breath. Thank you, I will. All right, negative 2. So negative 2. Open that parenthesis, 2.25. Close it. Hit x squared. No, I did not mean for that, but x squared is hovering right where this is. I got to get rid of this. It only needs to go on this side. Here we go. There's our x squared. Let's hit it. Now let's get it back on over. Oh, I just wish it would stay. All right, time to chill. Plus 9. Open that parenthesis, 2.25. Close it. Plus 18. Hit enter. What do we get? 28.125. And that is your y value of your vertex. All right, so if you were to write this as an entire vertex, well, just know that you would write it as 2.25. Actually, not even tell you, just to know. Let's just go ahead and write it. 2.25, comma, 28.125. Close it and circle it. That's taking the long way home. All right, let's get rid of our calculator for now. Let's move forward to number 7. What up, Trell? Trell launched a snowball in the air and can be graphed using the function h of x, which is y is h of x, equals negative x squared plus 11x plus 7, where h of x is the height of the snowball and x is the seconds it took to land from launch. Cool. Which point describes where the snowball starts? Oh my goodness. Where the snowball starts. All right, or let's just say when the times kicks in. So when I see that and I underline that for this one, I'm telling you now, you're just looking for the y-intercept of a quadratic function in standard form. Okay, we're not going back in time. All right, so the release of that ball, all right, if x is in seconds, well, our x cannot be negative. We're not going back in time. So our y-intercept is actually 0 and a number. All right, so why don't we take a look and just simply identify? If we know that our y-intercept equals, God, that looks terrible, 0, comma, c, well, if we have to start at 0 seconds because we're not going back in time, this isn't Back to the Future, and I'm not Michael J. Fox. All right, it is simply just going to be our C value. Yes, it is 7. Great job. So your y-intercept is just 0, 7 for this one. Go ahead and close it. Circle your answer. Onward and upward to number 8. Patty Boy Mahomes dropped a dime for 6 to Mr. Swifty himself, Travis Kelce, and his throw can be graphed by the equation h of x equals negative 0.5x squared plus 6x plus 7. Mr. Micro Machine, know its number, where h of x is the height of the football and x is the number of seconds it took to land. Which of the points describes the max height of the football? All right, what did you guys pick up on right away right here? Which of the points describes the max height of the football? And what do we know about the max or the min? Yes, the vertex provides that, and that is the y value of the vertex. So what I want you to write down is, because of that max, we're looking for the y value of the vertex. Now, that is up to you to plug into your Desmos or to find the axis of symmetry and plug in your x value to solve. But just to save a little bit of time here, if you did plug in the function, all right, your vertex would be 6, 25. Would it be the 6 or the 25? Yes, it would be the 25. All right. Moving forward to number 9, the dimensions of the table that holds the aquarium for Miss Myrie's pet iguana is 11 inches shorter than 6 times its width. Okay, write an expression can be used to describe the table in terms of width. Well, if we're working with width and we know that one of the sides, well, let's just go ahead and label the width. All right, and then the other side is 11 inches shorter than 6 times its width. So that means our other side is 6 times its width minus the 11. Well, if we were to write that function, it would simply just look like W, open your parenthesis, and in parentheses, you'll just do your 6W minus 11. Go ahead and close it off and circle your answer. All right, for numbers 10 through 12, use Desmos, and please utilize the tool below if needed. This will be all of your identifying over and over and over again. Yes, it just builds that comfortability. And no, I do not write these tests. So I probably would have had you just do it once instead of 3 times, but I guess it's once for each function. So I'm just here to adapt. All right, here we go. So you will be identifying the vertex, the axis of symmetry, all right, which is your x value of the vertex, the y-intercept, which will be 0 and a number, your x-intercepts, which will be a number and then 0. All right, use that tool if needed. For number 13, use Desmos and identify the point in which the word problem is looking for. Big hint if you're watching the video, it's one of the x-intercepts. All right, moving forward to number 14. Mr. Richards had an in-ground swimming pool put in last summer with a deck that borders 8 feet around the pool. The length of the rectangular pool is 2 feet less than the width. Letter A. Build a function that best describes the pool. All right, well, here we go. Here's our width of the pool, and the other side of the pool is 2 feet less than the width. Oh my goodness, so this would be W minus 2. So if we write our function, we will simply just write W and in parentheses, W minus 2. And then if you factor that out, or if you distribute that W, not factor out, that is equal to W squared minus 2W. Awesome job. Thank you so much. Let's move on to B. Build a function that describes the area of the pool building the deck. Well, let me tell us something about the area of this deck around the pool that borders. All right, it's 8 feet all the way around. So I'm just going to highlight that. I'm going to highlight this. All right, I'm going to highlight that. I'm going to highlight this as well. All right, this 8 right here goes here, it goes here, it goes here, and it goes there. So if we are going to build this function, well, take a look. All right, our W, perfect. Great job. We can do it with our W, but we will be adding 16 to it. All right, so we'll do W plus 16. Let's go ahead and write this out. So it's just so, you know what, let's color code it. We're taking this W here, and then we're just adding the 2 8s together to get our plus 16. We'll build that into the function. Yes, we will. All right, now for this one, all right, we have W minus 2. So what I'm going to do real quick, I'm just going to do it off to the side because you will have to combine like terms. It's very quick and very brief, but I want to make sure you're comfortable. All right, so again, that'll be W minus 2. We're simply just taking our original, and then we're going to add 16 to it. All right, so if we do plus 16 and close, well, we can combine some like terms here. All right, sorry about that it's not the greatest writing, but I'll circle my negative 2 and my plus 16, and then I do know that that can simply become W plus 14. And then let's go ahead and give it a close. All right, so now that we have that, let's go ahead and open this bad boy up. Let's drop our W in, plus 14. Go ahead and close it. Now, again, I will ask us to distribute this out, but if we do W times W, all right, we're going to get W squared. All right, and then if we do 16 plus 14 over here, yes, it's just doing like kind of a shortcut method because essentially we'd get a 14W and a 16W. So we're just kind of jumping the gun here and just simply combining. All right, but adding a W with it. All right. And I'll just write out the rest of this in black for us. All right, and if we did 16 times 14, that would be plus 224. All right, then it says describe a function that describes the area of the deck only. All right, so we're going to take the area of our deck here, all right, which is W squared plus 30W plus 224, which is the entirety of it here, all right, of our deck. So let's do W squared plus 30W plus 224. What I'm going to do is I'm just going to simply highlight this in red just so you can see exactly how we're writing the function, because we only need to write the function. We do not need to solve the function. All right, W squared plus 30W plus 224, and you're taking away the pool. Well, the pool is W squared minus 2W. Go ahead and circle your answer. Man, that W is bad, huh? And that right there will complete your review. That may not have been the greatest explanation for 14. All right, I tried to do it quick to explain it in the video so you guys can kind of visualize it and see it. Not going to lie, it took me a moment. It's why I went to Owen Fan Toes. Let's dominate this thing and let's crush.